Hi, I'm Dennis Spaeth. I'm with Micromanufacturing Magazine, and we're here at the MEMS Executive Congress in Scottsdale, Arizona. And I'm here with Mike Stanley, who's the manager of sensor product definitions with Freescale Semiconductor.
Correct.
And Freescale has a product item in the technology showcase here. They're one of 6 finalists at the MEMS Executive Congress Technology Showcase. And Mike has agreed to tell us a little bit about the Windows 8 Freescale 12-axis extrinsic sensor platform. And Mike, I know one of the things you were telling me just a few seconds ago was that this is a standard board, and that what you've accomplished here with your first foray into Windows is to keep this board and the 12-axis benefit in a standard format.
Well, let me preface it with saying that with Windows 8, this is the first time that Microsoft has required that you have a sensor subsystem on tablets and convertible PCs. So Windows 8 is essentially defining the product requirements. Microsoft put out standards in terms of how a sensor subsystem would have to communicate with the rest of Windows. So for instance, on this board communicates with Windows via a protocol known as HID over USB. This is the USB cable right here. Okay? This particular design is intended as a reference design. So it's not a design kit. You're not going to be coding with this. The intention is that this represents all the IP that you need to retrofit an existing Windows 7 PC board or tablet design or whatever to Windows 8. So essentially, Freescale is making available to our customers all the CAD files for this board, the schematics for the board, as well as information in terms of how to integrate into their design. On the board right here, we have a cold-fired 32-bit microcontroller, and it's running sensor fusion code to essentially take the outputs from a number of different sensors and calculate standard information that Windows is expecting to see. So for instance, one of the standard things that any type of OS is going to want to know is what's my current orientation of my device. And that's typically with respect to a standard reference orientation, which might be, say, pointing north, if you want to make it simple. So what's the rotation from that north orientation to where I'm at today? And we're able to compute that with software that we've embedded on this design. Essentially, we're feeding the output from Freescale accelerometer, from a Freescale magnetometer, think of it as an electronic compass, a Freescale pressure sensor altimeter. We also have a ROM light sensor on here that we're pulling in. We have a Panasonic gyro that we're using for rotation information. And we're able to essentially calculate all the parameters that Windows expects and needs for its 12-axis, or in general for its sensor subsystem. The types of information it's looking for. And the nice thing about this is that all the calculations are done locally. This means you can actually shut down, if you want to, your PC. And this system could be smart enough to wake it up. You know, so if you pick up your tablet, it issues an interruption to the main processor, you're off and running. So there are a lot of advantages to having what we call a sensor hub here within the system to offload the main processor.
Okay. And now this the setup here is just for demonstration purposes, but this is pretty much how it would work if you had it in a tablet. I mean, that's correct?
Yeah. The intention here is the user would literally take our schematics, merge it with theirs, connect up the power and ground of this design to their power and ground, connect up the USB port, and the native inbox drivers of Windows 8 will know how to interface with that design.
And this is in production already?
Yes, it is. There are tablets shipping that you can buy on the street today with a variant of this design in it.
Okay. And what is it that you're going to be demonstrating for the showcase itself tomorrow?
Essentially what I'm going to be doing is showing this particular board, and what we do is we package this up with some demo software so you can see the sensor fusion doing its thing, and we're going to show you that in a moment, along with the schematics, with the CAD files, with instructions in terms of how to integrate it into their design. The intention is that this is a one-stop shop for a PC manufacturer to get the subsystem that they need to retrofit their design. Everything they need is right here. So they won't actually plug this physical board into their design, but they will use the IP that goes into this board.
Okay. So, Mike, are you ready to show us a demonstration of
Absolutely.
how this is actually working here?
Well, this is a demonstration program that we wrote on top of Windows 8. And let me stress, this is a standard Windows 8 type of demo. So we're using standard interfaces built into Windows 8 today. And essentially what we're trying to do is to provide a graphical view of the type of information that we're pulling out of our 12-axis sensor platform. So the simplest one, of course, down here would be an electronic compass. So as I rotate my sensor pod, I can see my compass heading change. Okay? Now you'll notice off here to the side, we're also providing a three-dimensional view. Now compass heading is typically reoriented to the horizontal plane, but this one here lets us see how the device is moving in 3 dimensions. And that gyroscope is just tracking the movement of my sensor. Okay? Now we have several different types of information that are brought out on the display. We've got accelerometer readings, gyroscope readings, magnetometer readings, and over here we have what are known as Euler angles. So roll, pitch, and yaw figures, which are used for orientation. We've got over here another way of describing orientation, something known as quaternion. It's an advanced form of mathematics. We've also got the ability to essentially take our readings and log them into a data file. Now this is intended primarily for the engineer who wants to play with the data from the system, and maybe he wants to prototype something in MATLAB, for instance, so he wants to see how his algorithm is going to work. So we can give him that type of information, which I'm going to attempt to bring up for you right now. Here. And so if you can take a look at it, it's just a straightforward text file, so it's very easy to load into whatever your favorite analysis program is. That's not intended as a primary function of the tool, but any engineer who's going to be playing with this is going to love to have access. So we've made that available. Also within the tool, because of the fact we've integrated a light sensor, you can see the light levels down here, and we can see our pressure over there. That's air pressure. Air pressure can be converted to altitude when combined with the temperature, the ambient temperature. Temperature and pressure, I can convert that to an estimate of my altitude using some standard NASA equations. And typically you have to add in an offset to account for differences in the weather that day, but at least you can track differences in altitude as you're moving up a staircase, for instance. And typically today's pressure sensors are sensitive enough that you can actually measure the difference between, maybe 30 or 40 inches. So they're very sensitive in terms of their ability to resolve information.
Are there other, besides tablets and PCs, are there other applications that that you foresee?
Yeah, absolutely. You're going to find this type of sensor subsystem in most handheld electronic devices today. So you're going to find them in your smartphone, you're going to find them in your tablets and your PCs. You may find them in games, you may find them in control equipment. There are industrial versions of something like this that might be used for controlling devices that are moving in an assembly line. I mean, this type of sensor is prevalent in the world today.